Alright. And we are live. For the first time in half a month. I really need to get better about, like, weaving streams in with doing other things, because it's like, either I'm working on this and streaming, or I am doing other things. What is balance? No, we have laser-like focus in all things. No! That's not what I meant to do. It's my old D&D group's Discord back in Idaho. Just ignore that. Alright. OPSEC skill issue. Don't need to click too fast. I'm pretty slow at actually setting up these streams. Like we get the stream half set up, then we click live, and then we finish up setting up the stream. Client AST grep quit exit code 2 and signal 0. Well, I don't think that does anything, so we should be good. AST grep, is that like... That's like the search command, isn't it? Oh well. Okay. And then we'll just have that there in case we need it. Since we have been copying, just straight up copying Rust a ton. Have I actually gotten anything done since the last stream? I need to actually check, but you will notice everything is in different crates. I can't remember if I had stuff in multiple different crates last stream, or if that's something I've done since then. If that is something I've done since then yeah, it's a big improvement. A lot of work. How's my day been? Good so far. Not super eventful. Just kind of... I've been very much thinking about, like, how much coding language is actually needed for all this. Because I realized, like, I've been taking forever to get this actually done. When, like, all I really need is a well-sandboxed C clone. But here I am going and, like, copying a ton of, like, very high, like, advanced language features that if I do get working, are amazing and make, like, all of this a lot more ergonomic. But it's taking it's like nerfing the takeoff velocity. Like, when it's working, it's going to be awesome, but it's going to take a hot minute to get working. And, like, I've been diving into, like, Udon Sharp and making, like, some VR chat tools that just, like, directly output Udon Sharp, assembly. Well, not Udon Sharp, but just Udon assembly. And, like, if you look hard enough, you can find the decompiled source code for Udon, the virtual machine that VR chat uses, to actually run their code. And it's like the actual core functionality is 300 lines of code. Like, it's just one switch case block with 5 cases. Actually, no, 9 cases, though 2 of those are no ops. So it's more like 7 things that VM can do, and as a switch case. And yeah, that's the entire thing. That's all of Udon is resting on top of that. And that's also why it's incredibly slow. Well, not necessarily why it's incredibly slow. It's incredibly slow because a ton of the runtime uses string operations for like sending events to other Udon behaviors and whatnot, and that's just completely unavoidable. Can't optimize it out with how it's designed now. You could optimize it out if you designed it better, like very briefly. But yeah. And then like I'm looking at this and I'm like, the company that made this raised like hundreds of millions of dollars. And they did it with this. I don't need to build all of this. I'm like, this is not the smart decision, smart business decision. It's the very smart technical decision. Like, after I get this done, it's going to be amazing. But if I just wanted to get a business thing that worked, I could put in a lot less effort than this. And I was like, what if I pulled a JavaScript and got like a C clone working in a week? It would be so easy, and then it would just be working. But no, I do think this is what I'm doing now is the correct thing to do. However, there are easier ways. And that is what I've been realizing recently. We don't need something that is the best. We need a thing that works. Well, the market needs something that just works. And that's what they'll accept, but my standards of code are higher than the people who use my code. Who will use my code, if that makes sense. Alright. But to kind of bring everybody up to speed on where we're at, the language works like this. We have text. This gets turned into a token tree. And then this gets the tokens and token trees get turned into an AST. Pretend this is an A. And then this AST gets turned into HIR, or high level intermediate representation. Drawing with a mouse is hard. And then HIR gets lowered into, in other languages it gets lowered into mid-level assembly, so MI, or mid-level intermediate representation, MIR. And then MIR is, I am currently undecided if I actually directly run this and transport this over the network. I believe the representation of, like, the part of LLVM that you use to actually describe stuff when you're using it as a backend is MIR. So it might make sense for this to be the final representation. That's just used everywhere. We run optimization passes on this, etc., etc. Actually, this probably will have a little bit more debug information and like type checking things. So we'll probably have to have a further lowering step to just IR or bytecode. And currently, we have this section of the pipeline working. We have the actual data structure for the HIR. I think earlier today, I finally finished the data structure for the HIR. So now, what we have to work on is, not that, is this. we need to work on lowering. If I can... Yeah, lowering. To the process of turning AST into HIR. And there's several factors that go into this. The main one is that all references inside of a document, actually just all references in the entire codebase, are resolved during the lowering phase. So in the high level intermediate representation, you'll see we have these HIR IDs on each one of these nodes, and on things like path segments and paths themselves, they have this res field or resolution field. And what that means, and this is actually probably the last part of the document I actually need to resolve or write, is this actually resolution. And what this is this is a reference to a node somewhere else in the HIR tree that represents what the thing is. So, for example, if we have a path that is something like standard, ops, and then add. And this is like the add trait. For this is what the add operator uses. The way that this path is represented is this is a path segment, this is a path segment, and this is a path segment, and all of that is a single path object. So this res here would point to the add node out of so all ASTs are for separate documents, but HIR is for your entire project. Everything in the entire project is in the HIR, and the lowering stage creates all of the HIR at once. There is, in the Rust compiler, there is some potential for caching. At first, we're not going to have caching. We're just going to, every time we compile everything, which we will definitely have to change at some point, but for, this first initial version, one, our codebase probably won't be big enough for that to actually matter. It will quickly become big enough for it to actually matter, but to start, it doesn't need to be that massive. So, yeah. But then, each one of these path segments also has a resolution. So this here, this would point to the standard module, so the standard library module. Then ops would point to the operators module. And then the res on this item would also resolve to the actual trait. So you would have a duplication of the res here and the res here, both pointing to add, I believe. I haven't double checked that. But that means when we're actually doing analysis of the document, we don't ever have to re-look up symbols, because the data structure just has all the references already resolved. Yeah. Where before, when I have built other languages, or the other versions of Brane script, in fact, I didn't have this progression of data structures that we're doing now. What I had was, we created an AST, and then we built the code just straight from the AST. I did kind of have compiler passes, I think, maybe. But it was just continuously iterating and modifying the same data structure rather than like this. Let's have a data structure for each, like whenever we wherever I would have modified a data structure, Rust instead creates a new one. So you just have only the data that you want in there left, which is a different way of going about it that I kind of like, but it requires a lot of boilerplate, so it's taking forever to write. Okay, res node we need. Is it either type or res? Let's just look up res and see what we find. Space and then res. R equals res. Let's click on this and get the enum. HIR. Oh wait, no, that is an enum. Oh, it actually took us there. This is because this is in a different folder, HIR defs. They're not being that fancy to split stuff up into that many files yet. But let's look at what things can be resolved to. So we have a definition. Definition having a unique ID corresponds to something defined in user code, not bound to a specific namespace. So this is probably, oh, def kind. So this is a different enum. And then you have your primary types. So things like integers, floats, strings, self type. Okay. Self-type alias, the item introducing the self-type alias. But what is the difference between the self-type parameter the self-type is used within a trait. The self-type is used somewhere other than within a trait. Okay, so this is the trait flavor of self, and then this is the flavor of self used within anything else, where we already know what self is. In the case of trait, we don't know what self is. So it's kind of like writing a generic function, I guess. So I don't know if it actually needs... Yeah, so this is a reference to the trait. All you missed was me going into an explanation of like HIR and like the whole tool chain of the language. Potentially. I don't know. Right now I'm trying to figure out how types are resolved in the Rust compiler, like what the data structure looks like. And then we're gonna go and actually implement it as soon as I finish writing this. And I think I can ignore the majority of this for now. Like we can do def kind, and def ID. that makes sense to have that. Then we have HIR primary type, which... Do I already have a primary type? No. So let's check what that is. I mean, that's how it goes. We'll get it done very fast now, though. Not def, we want HIR. And then we want... Okay, and this is part of the... We have some, like, AST related nodes here. Is this another not directly represented in the AST thing? Or... List int type... Literal kind... That's a literal int type. Which does take in int type. Okay. So literals do require this. Should I copy the Rust string slice system? It's a good system. But the language does try to do sneaky things, like have most functions secretly be generics. So when you have a str type or any slice type, there is the potential possibility of that being passed in as differently sized types. Where I wouldn't be doing that, it would just always be a slice type. Oh, they don't capitalize the I in int. That's interesting. And then does did I define? No, I didn't. I didn't define integer types. In fact, I didn't define literals in the AST. I just kept using this. You know, just keep this one literal kind throughout the entirety of the document. For the HIR though, I should probably upgrade this type. Seems like a smart idea. Okay, long intro to the song. I was scared my internet cut out. But do we define these in the AST? Well, I guess, yeah, if we're going through the effort of adding all this, we should add it to the AST. Here we'll change this to lit kind. This kind's pretty lit. Why no music? Oh, did I? Oh. I accidentally bumped my volume knob. There is music. Here in TY kind. Yeah, we'll do it above type kind. No, we'll just do it here at the beginning. And then we're gonna copy this. So int type is in this file. So let's see, string literal. Okay, there's the lit kind. And then we're going to no longer use that. Instead, we're going to export literal kind itself. And I currently don't have string styles, so I'll just leave that out for now. We don't have byte strings, we don't have C strings. We don't have byte chars. Do I want to do character literals? Yeah, let's do character literals. What's this poll 128? Is the literal int type? Oh, okay. I see what's going on. This is the value for it. Then, is there a literal struct anywhere, or is it just literal kind? And then symbol, this is like our interned strings. We already have that. So we'll do literal int type, literal float type. And here I was thinking I was done with the data structure, but nope, we immediately find more of the data structure that I need to implement. I promise we will get to actually implementing lowering by the end of this stream. Now this is making me wonder if this is represented in the... Wait, this is the AST, so I would be like parsing this from the token tree. Oh, that makes so much sense. That makes so much sense. I just figured out how the data structure of literals like work. You don't need to represent them. I was thinking of literals as one token, like the if you had, for instance, like 0.0f, for instance, like this would be a float literal, like one singular token in the stream of tokens. But no, you can represent this as 4 tokens. We have a literal 0, like an integer 0, and then we have a period, which can be represented as a punctuation token, another literal integer, and then an f, which can be represented as an identifier. So I could add this into the parser instead of the lexer. That would make it a lot easier to parse, and also means I don't have to upgrade the current representation of token literals. That makes sense. Makes a lot more sense than just doing it in the token stream. Because then you can just let the token stream do token stream things. And then having this in the AST as a new data structure makes a lot more sense. Oh. Ah! My alarm is going off. Ugh. I expect it to be that late in the day already. But I'm gonna ignore its intended purpose. Wait, where's float? Where's float? Prime type float. Okay, I just missed it. It's very important, especially in game dev. So now to implement these, I wonder why there's a string literal. Because there's lit kind. Why is string literal a different data structure? I don't know. Oh, it's importing in type. Oh, this is HIR. Never mind. This should be able to support full equal. Not just partial equal. Okay, and there's probably, yeah. Wait a second. So this just has lit kind. Is there anywhere where I actually need like a literal data structure? Meta item list. No, it just looks like they use literal kind directly where they need it. No span information or anything. I guess you inherit spans from most things that reference literals. And then we add the span in the actual HIR side. So if this is a lit kind, it is lit. Oh, this is complaining. That's actually an enum. So permi type and definition. Do I need anything else? Def, primary type. I don't care about self types at the moment. I do care about local variables or function parameters. I wonder what ID is. HIR ID, okay. I guess this will resolve to this will probably resolve to a work with me here, Brane. Like a let statement. Somewhere where we actually define a variable. Either a let statement or a pattern match block. The spot in the code that defines it. Which means now we need a definition kind. Yes, def kind. Let's figure out what def kind is. Ooh. We actually do store what this is a reference to. Local probably should store what it is a reference to. Alright, this is going to be another copy the thing straight from the compiler, or straight from Rust, and then comment out most of it and label them to do. So I'm renaming modules to groups because I want modules to be lined up with compile units. should fix that. Cool. So we have a structure, union, or don't know that I'm actually planning on supporting unions, because enums kind of just fully take over the job of unions in most cases. And I don't think well, I'll just comment it out for now. We have struct, enum, variant. I guess that's a variant in an enum. A trait, a type alias, which I'm not planning on supporting quite yet. For to do on that, type from an extern block. Put that in a question mark to do. Trait alias, which is also a to do for now. Associated type, this is another to do. Type parameter T in the struct vector T type parameter. Okay, I'll keep that since it's for generics. And I do plan on adding those fairly soon. Value constants, we don't have constants yet. If I'm keeping type parameters in, we'll keep that. Constant parameter. Constant generic parameter. Static. Oh, this is a global variable. I'm not currently planning on having any form of global variable. And if I do, it's not going to be called static. I very much want to really lean into every single function types and pipelines being fully pure functions, and then like if they need to interact with any form of data outside of themselves, they do that through the asynchronous scheduling system. So they might be able to get global references to things, but to actually access or mutate the data, they need to do like an async locking operation. Essentially, they need to request the data. First, the struct or enum variants constructor. Rust doesn't have constructors, though. It has new functions. Like, there isn't actually constructors, they're just new functions. Constructors don't exist. At least that's what I thought. Yeah. The only way to create a struct is through a struct expression. And I don't think you can directly refer to that in the actual grammar. Like, a path will never resolve to a thing's constructor, because constructors don't exist. Enum variants have constructors. But that's more so a reference to the variant instance itself. Oh, this is an RFC. Oh, this is closed. Postponed. Okay, so I don't need to worry about this. This is a in progress language feature. Constant parameter associated function. Oh, so when you're doing implementation, an associated function is one of those. An associated constant. Did I keep constant in? I did. Actually, it would be a foreign module and potentially foreign groups. I'm gonna say to do with the question mark on this. Not namespaced where they are, but we don't treat them as they are. External, great. I'm gonna say extern module because in BraneScript modules are the same as crates in Rust of like that is the compile unit. Anonymous constant. The 1 plus 2 in the so I'm wondering why these have to be resolved. Like, because I don't know how you make a path to this. I haven't seen resolution fields in anything but paths so far. Oop, opaque type, field, lifetime parameter. No lifetimes. Now, I am going to have affine types, but not using lifetimes, because I am not going to try to get devs to use lifetimes ever. I don't think that's a game dev thing that will work. And closures are also a to-do. Synthetic coroutine body. We don't have coroutines. Everything is a coroutine. Or at least every pipeline is a coroutine. There we go. That takes care of definition type. I guess defkind might be used in different places than just lookups. So this would have to be any type of definition. And then when we look up a definition using a resolution, you would use defkind. In which case, this should store the data of those things. I don't know. Let's see what a def ID is. Oh, that's under the span. So this is def RS from Rusty Span def ID. We want def ID from span. Context def ID. Rusty Span. This a pub use def ID. It's not a public use, but they might redefine the type. There is an implementation for it. Public mod, def ID, def ID, ID, ID. There it is, struct def ID. So we have the definition index, the crate name. I guess this would be spelled with a K, crate. I wonder how that got past the PR. They're like, I'm gonna call it crate, and they're like, no. Or it might be grandfathered in. Wait, why are there two definition indexes? Configuring the order of the fields so that def index, which is high entropy, always ends up in the lower bits, so no matter the endianness, this allows the compiler to turn a hash. Do direct call to use before hash. I don't know what that's about. They are really optimizing that. But I'm guessing we only need one of these. A def ID identifies a particular definition by combining a crate index and a definition index. So I guess... Ow. Oh, I just stretched too hard. Ow. So I guess every single definition in a module or crate, in the case of Rust, is just indexed. Well, I can work with that. So let's figure out what def index and crate num are. Will that work? 0 constant on. Let's just go with 0 then. Oh, while I'm here, I should probably look up local def ID. This is just a local def index. I'm gonna move primary type so that it is back with literals, and then we have all these resolution related types at the top of the file, which makes sense to me. Owner ID is not represented here. Owner ID is probably just a definition ID. That's in the HIR ID. Yeah, it's just a local def ID. Hello? ID? There we go. And then an HIR ID. It's a combination of Alright, what is an item local ID? Why is there so many ID types? Another no type index. I wonder what Rust index new type index does. Probably defines a bunch of member functions automatically for it. I don't care though. This is going to be gonna be a U64 for now. Cool. Possibly, maybe this should be implemented. HIR doesn't implement debug. Okay. No diagnostics popping up, so it's possible that after several weeks of fussing about this, the HIR data structure, the structure of the data, not the actual functionality, but the data structure itself, might finally be ready. Possibly. Yeah. Which means it is finally time to start work on the lowering system. Then after we have lowering done, we get to implement type checking, and then after type checking is done, because type checking is really the main operation we need to do on it. After we do type checking, we do lowering again. And then after that lowering is done, that is when the fun begins. That is when we Brane, work with me here. That's when we lower to HIR, and HIR is what can actually run. That's the code that can actually run. And then I briefly consider writing an affine type checker. I discard that, and then we move on to getting the runtime working. And then I go back and make an affine type checker after the runtime is working. Alright, I'm gonna hit the bathroom real fast, be right back, and then we finally make an HIR lowering system. We took an hour into the stream to get to that. maybe possibly soon. It sounds like a hard timeline to me. I know. I'm not actually in front of the camera yet. It's because my head is on the ground. What? All right, I am back. Finish resetting up my desktop and shifting everything into place. All right, and then let's center. All right. Oh, let's center more. This direction. Come on, Meta. Have your hand gestures work, please. It's like I have the gesture, and then the instant my fingers touch to activate it goes away. Okay. We are back. All right. I believe from this point on, I really only wanted to copy the data structure that Rust uses, but not the actual functionality. So this is the point at which we stop referencing the Rust compiler. And go off on our own. We are we're copying the pattern, but not the actual functionality, not the actual important bits. So let's see. Real quickly, I need to check to make sure, yeah, the literals are parsed correctly, because we refactored that. So literal kind here is string, integer, which it can be an unsigned integer. In this specific case, int float true false. Which means I think I also need to mess with the tokenizer very slightly, since I changed that one type. Yeah. Map int. Let me see if it can just infer type. Because from string should be able to infer this, I guess. Maybe if I put an explicit type in. Oh, what was that? Okay. Now that I understand what these literals are actually doing, makes all this a lot easier. Okay. And then up here, we have a literal expression, which is any ref labeled literal, token tree literal. So I have the literal expression. Where is literal expression used? Man, my LSP is just crapping itself right now. Yeah, there's some long-running job that's stuck. And hopefully that session doesn't restore it. But... yeah, so we have literal expression here. But what we actually want here is a choice. I'm just gonna have this here be a literal token, and then literal expression is actually going to be a choice between let lit float let literal int let string. Let's see what kinds of literals we can have. And we'll order these accordingly. Lit. I don't actually have the grammar for a char, do I? Actually, I do have the grammar for a character. Technically. Maybe, kind of. Actually, I'm not sure now. Just not sure if that should go in the tokenizer, or... so we have a literal... So pub use lit kind. Okay. This is just using the kinds of literal. Oh wait, this is just an enum. Of course I'm not finding references to it. I'm dumb. Here's the actual literal with literal kind that I can look at here. So there is a character literal, is one of the things that this can be. So here's the thing. Like, I could represent literals as things from the token stream. Like, string... No, string shouldn't be a group of characters. So I can't... I wouldn't be able to represent strings as token trees. But we do want to represent a character. Okay, no, they are appearing to represent suffix. Dang it! I thought I could get away with making this easy on myself. Then we can do just F then this can be 32 or 64. There's a choice. Let me see what... Oh, it's just a symbol. I guess I could say ident. Because that wouldn't match white space, meaning spaces would work. So then when I do a literal, here, and yeah, we can just parse it, actually parse it later. When we lower to HIR, I guess, is when this happens. Wait. Which file is this? That is the AST. Okay, I don't want to make that simpler. Me. Oh yeah, we're gonna do lowering when I come back. Me when I come back. Alright guys, we're gonna fix the syntax for literals. Okay, so this is the literal kind that we want to mess with. Lit kind string. No, I'm keeping these as short variables, because screw you. AST only must never appear in a token. Okay, I actually understand what that's saying now. That makes more sense. So Boolean, I'm not gonna worry about bytes. Character, integer, float, string, not true or false since we're doing the parsing later. And that is all we need for now. Wait a second, can you put a suffix on, like, strings and stuff? Suffix. Yeah, that's a suffix on a string. It followed B immediately without any spaces by a suffix as described above. Like any literal, the suffix may not begin with an E or E, as that would be interpreted as the exponent of a floating point literal. Effect of these suffixes. Invalid suffix. So this is grammatically accepted. But, or maybe this isn't grammatically accepted. I don't know. But that is cool that you can do suffixes for other types. I'm gonna remember that, because one idea I had is, like, format strings. I always forget that I'm gonna write a string that has formatting. I'm always like halfway through writing a string when I decide I want formatting. So I think it would be cool to put the syntax, like, the little, like, thing that indicates, like, a format string at the end of the string instead of the start of the string. Just because that would make it easy to write. Maybe, I don't know how readable it would be though. That's my main concern there. Display for literal kind is completely screwed. Yep. We're gonna do display for literal. And then we're just gonna do write this symbol. And then prefix, actually. Oh no! Oh no, my music! Okay, it's still playing. Good. My internet didn't go out. I'm getting traumatized by how often this internet goes out. So write and then self symbol. as string. Okay, so it is correctly remembering symbol. And I just won't worry about the suffix displaying for now, maybe? Actually, let's see, self dot suffix. There we go. My conscience is happy now. I'm correctly displaying literals. So now I have to properly actually parse these. From slice to string unwrapped. Then I'm gonna say, and then I'm gonna say, then. Then ident clone or not. Maybe that works? Oh, it does. Doesn't complain about splitting up something that doesn't exist. That is good. Why this one isn't complaining is beyond me. But this will have to be a literal. And we'll put in kind. And this will be a lit kind int. With a suffix, which is I guess I have to map the suffix. Oh, see, the thing is, it can be numbers, too. And technically, identifiers should be able to have numbers in them, too, so ident does still work in this particular case. Like, that's a valid variable name, right? Parser that accepts a C-style identifier. Keyword. Oh, it does have a keyword. That's cool. Do I have anywhere where... That's the parser. Do I have anywhere where I would need that? No, it's mostly just. But if I wanted any keyword tokens, I could do keyword tokens. Okay, so I don't have to worry about this handling identifiers incorrectly. So I'm gonna actually break this out into its own thing. No, I'm gonna break this out into its own thing. I don't need to, I can just directly call the function. Now I don't need to match the suffix. Instead I need to do the same symbol intern on the suffix string. And then I don't actually need the int value. Actually, I do. I need to do toSlice. That will give me the int text. Found an option. Ooh. There we go. That's actually pretty clean. And then this is going to be a literal kind of float, with this being the float, this being a float, and the rest exactly the same. And then for the actual string itself, I guess we just keep it exactly the same. We do lit, and then kind is lit kind string. Symbol is symbol. Intern the string. And then finally we need the suffix. In this case, I'll just set to hard-coded to none for now. Nice. Now these are the way that they actually should be. Do I want to add booleans into here as well? This is going to be text ASCII keyword, since now I know what that is. True. False. And then we're going to map this. Oh, actually we want this to slice. And have this be keyword, and then this is mapped to a literal with a kind of literal kind boolean. These boolean. Symbol is symbol intern keyword. Symbol interning is such a cool technique. we're gonna say character. Oh, do I have to? I have to represent escape characters as well, potentially. Maybe? Possibly don't need to represent escape characters. Maybe not. I might be able to get around that. So we want to do a character is an any, and then it is a just, or actually, it's just an escape character. How do I do strings? I don't know if this handles escape characters correctly. C style identifier. Identifiers don't have escape characters. Which means I need to figure out how to handle escape characters on my own. Doesn't have escape characters because there is no escape. True. Is it possible to do a not character? Oh, wait. If I do it like this, if I say let escaped char equal just the like escape symbol, and then say or not that can exist or not, and then any, because any character, that now matches this and then an any character, meaning if this shows up, we must match an any. So now escaped char delim. Then I'm gonna say as for to slice, because we want this to be no, we don't want that to be the text portion. We want to let the implementation handle that. Here we want to say to slice Then delimited by come on, I have to have used delimited by all over the place. Maybe I use that in the... No, not... I wouldn't use that in the AST. Do I use it in... the tree parser? Why am I... Oh, this is a literal tree token. Is the tree itself spanned? No, it wouldn't be spanned, so... we need tree literals to be... I'll just... Is it worth adding a span to this literal? Because I do want this to hold the entire literal. And that looks correct. It's not complaining anymore. Okay, and now look for delimit. There it is, delimited by. Which I'm not quite sure why I'm not using in the token stream. I remember it not being in the examples, and maybe that's why I didn't use it. So we want escape char to slice delimited by just a good example of the reason why we have this specifically as a delimited. Or escaped character. If I did ignore then, would the slice include this? I don't know. I guess I'll figure that out eventually. Should take care of it not being able to do type inference, because then it's actually being used theoretically if I throw it in there. Then when I do a string, I do escapable char. But how do I say that this escapable char is... See, this is the example for string. Wait a second. Oh, okay. It's not actually handling escaped characters. It's just the example needs to have escaped characters because, yeah, because it needs to have parentheses in the string for it to be able to parse said string. Can't I just pull a delimited by? Like if I do escapable char repeated escapable char needs to be a function. Escapable char, and this will take in a character, a delimiter char, And this will return a parser. Actually, I really don't like inline functions. I was like, oh, this might be the case for one. No. No. I'm very biased against them. They just, like, really don't look good. Lambdas are, manageable. Like, lambdas are a necessary evil, like a local scope lambda. But yeah, I just really don't like inline defined items. Like, don't declare a structure in a function body. That's So this will be a choice. Between this and then an any, or it'll be a none of just the delimiter. See? Either you can do any token if it's preceded by this, or you can do any token but the delimiter, or any character but the delimiter. Big brain. This'll work. Turn type was inferred to be choice. What? Okay, how did I handle this? It's an implementation. This is an implementation. What do you mean? This is an implementation. Like, does choice not implement parser? Choice should implement parser. Yeah, parser's T. Yeah, none of is a standalone. Yeah, see, it implements parser for none of. Then I know then implements parser. Maybe this parser doesn't return what I think it returns. Here. We'll just do a macro then. We need a literal, so we go macro rules, and then this is an escapable character. And then we want a lit. Oh. I've never actually written like macro rules because the syntax is a pain to learn. So we want a literal expression. And then what we want to put in there is this. And I think that does the same thing, where if I do escapable character, and then do the same thing, that gives me a literal? Nice. And then that's just in line. Then escapable character repeated. Nice. I am actually really proud of figuring that out on my own. Affected tuple char found type char. If I do ignore, then it should resolve to there just being one character as output. No tuple. Yeah. Now I need to test out escape characters. Or string literals with escaped characters. Turning this value requires the source to outlive static. So what have I added to literal? Yeah, something about what I did to literal made it so it's keeping in a reference to something forever. Symbol can't store a reference. That's kind of the point. If I remove literal, does it fix the problem? Yes. Can I just do that? Can I say automatically find the thing and then make it static? Apparently not. What part is needing to outlive static, though? Source must outlive static. See, but I do a map. And token doesn't store any lifetimes, right? So how is... But here's the really weird thing. So I map that, I map that, I map that, I map that. Oh, this is so the internal slice is the correct content. Got it. Symbol doesn't retain anything. Does literal kind have any references to anything? No. Okay, there are some unwritten files. I saw a couple flash when I did write all. So writing all might fix it. Nope. We do get a no field literal kind on Brane C tokens. Technically the Lex or that's tree. So tree is getting compiled afterwards. Where's the lifetime coming from? Where is the lifetime coming from? Suffix is a symbol. And there's no references in the entirety of the token itself. Or the Brane. Ooh, I do want literal to appear for ident. Good. But like I map them. Mapping them should remove any lifetimes that they require. source? What's that? What is giving it the lifetime bound? Okay, what if I don't use the escapable char macro? Same issue if I do that. Yep, same. Oh. Wait for it to reload. Yeah. What if I comment out character and string? Does that fix the error? It does not fix the error. Let's explicitly define this mapping. Just to be safe. Is it Boolean too? Since Boolean does have those ASCII keywords. Okay. So, the problem is since I'm doing 2 slice, this is setting up or introducing a lifetime somehow. And that lifetime's not getting taken care of correctly. Or not being removed. What's the dot lazy do? To ignore trailing tokens? Okay. That's not gonna help with lifetimes. Dang it, I'm so close. Let me get to the lowering. I just want to get to the lowering. What if I throw that in there? Requires the source must outlive static. And its source is static. Oh, wait. The input is source. Keyword is S. So source input is a reference to a static string like that. Or is it? requires the source to outlive static. This does not require the source outlive static. Like if I throw a lifetime in here, it doesn't do anything. Okay, no, that is still erroring. Wait, is it because... Is only bool the problem? Because it looks like it's trying to tie the lifetime of this keyword to the lifetime of source. So if I comment out bool and then we throw bool into the comment gulag, is compiler happy? Yeah, compiler is happy. So it is only Boolean, not the strings, but Boolean that's causing issues. Because for some reason, having these keyword true and keyword false. See, but if this parser lives for static, wouldn't it allow the other ones to live for static too? keyword.borrow. Why is it manually doing borrow? Anyway, I'm gonna try manually implementing this. Oh wait, it's already doing toSlice. That might be the problem, is that I called toSlice when it looks like keyword already calls toSlice, so I'm trying to get the slice of a slice. If it's just that, that's kind of dumb. No, it's still complaining. Grammar is fine, though. I'm just gonna do the try map manually. That way there aren't any weird lifetime bindings being forced anywhere. Dang it. Just let me do the thing. It is doing a label error expected found. It is literally doing a label error where E is error with the label error. Oh, wait a second. No. Is maybe it's because it doesn't know exactly what to return from here. No, why can't it just work? Why can't you just work? Trait label error. Who implements it? Cheap, rich. So rich does implement it. So if I do Lexer error like that, cannot satisfy the lifetime for input. Expected found. Expected E. Can I see the implementation? Why do none of my registers have the thing that I actually want to put in there? Expecting type bool. Is that what I was having trouble figuring out? Man, these errors tell me almost nothing. Cannot infer the type parameter I declared on the trait label error. So label error I. As label error, and then input source uses maybe I token, and this uses I span. But you're right, expected found doesn't really... Yeah, that really doesn't have anywhere where it can infer I from, except for the span, which it could infer the span info from. Theoretically, because this option is never defined. I'm actually gonna try that. What happens if I just define the token that it's trying to find? option, and then this option. Source, and then the actual input is source, and then the token type is char, I believe. Not satisfied. Which lifetime? I declared on the trait label error. Okay. I guess I will just manually define the trait here instead of doing it anywhere else. That's the I input source, which is a oh no, those two lifetimes need to be the same. Oh, L. And that is... okay. As Chomsky input token. Okay, if I skip this to source, it'll figure it out. No. Why did I have to specify those generics manually? It's fine. Maybe if I had manually specified a return value for the lambda, it would have been able to figure something out. Instead of having to manually specify every single generic argument there. But it's fine. It's working now. Maybe. And the lifetimes for the entire function aren't complaining anymore because I declared the mapping function manually, which figured out all the lifetime things. Yippee! Okay. Now. Now we can actually move on with our day. Just need to go to tree RS. Something in my editor is crashed right now. Right, because try map I didn't actually... Oh, we didn't actually implement the... the success cases. It just only failed. Only fails. Lit expression clone Brane C par. Oh, that's in the parser. Well, I'm glad I remembered to put this in. Otherwise, I would have had no booleans. No booleans? But yeah, the error was in the parser, which is where it should be. Literal expression, choice with no choices. Ooh, do I have to try map this? I might have to try map this. Potentially. See, what we need to return here is an AST lit kind, I believe. Then what this must return is an AST literal kind. Then we need to return match on literal. Never mind, we try match on lit. Can I have a thing to auto? Yeah. LSP, do your job. Make me have to do no work. If I do that pattern matching. Can I pattern match that? Where is it getting spanned from then? Well, that works now, which is nice. Oh, if the span... I just want to unpack it. Is it still unreachable? Any code following. Code is unreachable. Yeah, but it's saying that the match itself is unreachable. Or maybe it's just all these to-dos. Going like the return statement won't be reached because... Yeah, that's probably it. AST lit kind boolean. Nice. Okay, and now if this is a lit kind char, then we want to do another match on on the symbol as a string. I've spent more than 2 hours on this. I did not realize that. Guys, parsing is important. Data structures and parsing are important. Okay, now I need to deal with literal int type. Oh, wait a second. I can just do I-128. There should be a try from or string. Alright, I'm gonna try out a new pattern I learned today. which is an if let or a let else. No, actually a match makes sense here. I don't get to try out the new thing. But the trait bounds, or that's the Chomsky parser. Oh, it's from the type itself. Or not the type, it's from string. Let's see, we have a value. Now we need just an int type. We need a match on the suffix. Split int kind, unsuffixed. This is that name code path, but if it is suffixed, dang, I do have to specifically match the correct suffixes. That is something I need to do, is specifically match the correct suffix. Otherwise, yeah. Int could match on F32. Like 0F32 would match on int right now. I'm just gonna to-do this for now. Alright, let's copy this for float. Unsuffixed values will work. And this will be a literal float type that is unsuffixed, and therefore it will try to inherit its value. Now, if only we had implicit type finding. Or not typed, implicit type resolution, I think is what that is. Trait bound symbol from string is not satisfied. Yep, and there is an as string. Saying symbol from string. No, I don't want to do symbol from string. Oh, wait, for this float literal. That's right. The value of float is just... literal kind float has it as a symbol for some reason. Where we directly get the integer value, for some reason float is still stored as a symbol. I guess no pre-processing really uses floats, so you don't necessarily need const float symbols. I think we're properly handling mostly, except for in the case of suffixes, which I'm not actually a fan of how the Rust compiler handles those. But for some reason I followed that, even though I don't like it. I may refactor that in the future when I actually get it working to work the way I want it to. Okay, brain cooked. Learning more about face tracking with Quest Pro, and whoa, it can track so much of the face. It's a shame that none of that is translated onto Meta's default avatars. Wait, really? Are you talking about like the Horizon Worlds avatars that have like the extreme baby face? Come on, Brane, be fast enough you can tell jokes. The extreme baby face blend shapes. I don't know. There's something about like the like face talking movements of meta avatars that, yeah, that messes with me. Also, there are like, I guess, the test avatars for Oculus stuff. Like, I've seen really good looking avatars that I think were demo ones, but they were still, of course, like uncanny valley. The other problem is like with how like network hungry any VR application is. Like we're already trying to send the data of like hands in real time, each like individual hand bone. You can't see like I have like an outline of like my actual hand, but like that's a lot of data. And I bet my avatar is still sending the data for my other fingers, even though like, you know, they're not part of the actual avatar. Like that's a fair amount of data to send every frame. And if it's like a whole lobby, it really adds up. And then if you like animate every single face bone, that's like another set of hands, which it's a lot of data. No, it's still complaining about the parsing. But we're not parsing, so I don't need to do that. Can imagine if they were open using the Chrome browser. This is true. Well, that's RAM hungry. I'm talking about network bandwidth. And like specifically network bandwidth that leaves your house. Like there's a lot of LAN network bandwidth. Right now I'm using this headset over the like LAN network, and I have 2 windows and a full like field of view. Then again, the windows aren't streamed separately, but like I have like all the network bandwidth I want on like my personal router that I have like tucked behind the PC. But whenever you're trying to talk about like data leaving your house and coming back, that is like significantly restricted. And then if you're talking about like, if one server has 80 people in the room, imagine how much data is just being shoved through that server. It's a lot of data. And that is why the ISPs charge us for it, yes. But even more, for the platforms themselves, it's more expensive because they're having to pay the data center, the ISP, that data center ISP is more hungry. Dang it, to do, you're supposed to let me just like not worry about that branch. Wonder if photonics computing, with its bandwidth across many frequencies of light, would be the networking version of fusion power. Well, the networking version of that is fiber, which most ISPs don't offer, I think, unless you're like in a large city. Like, it's harder to get fiber, because that is light. Potentially multiple bands. Like, I think the more man, it's been so long since I took CompTIA. I know there's like a version of fiber optics with like 3 light bands or more. Implement trait is not allowed, and do you? I want to have my trait. Say result is an AST lit kind or an error. There we go. That should make all of our inferred type checking a lot happier. Like, we might even be able to delete that now. I don't trust it though. Let me guess, this is now going to complain that this is not... Oh, wait, we want this to be an OK. Oh, they're actually using it in hardware? That's interesting. Like, we've reached the limits of copper that much that within, like, a space this big, you need, like, fiber optics. Like, I know that we are, like, brushing up against them, but the fact that you can actually, like, get something working well enough that it's worth it is kind of crazy. Is it, like, I know, like, they're server rack tray size things, so it's, like, more like a meter long, and then, like, I could see fiber optics being useful from device to device. But I'm interested if it's like inside of one device, there's fiber optic cables. Expected unit type. I mean, expected unit type. Oh, it's saying this expected unit type. Okay, what if I just put this match arm first? What are you gonna do then? It's a to-do macro. Screw you. It's a to-do macro. Why isn't my to-do macro working? Using LLVM? How is it? I really like using LLVM. It's a little less documented than I would like, but at the end of the day, it does the job pretty well. Though right now we're not fighting with LLVM. We're fighting with just Rust, to be honest. Oh, was it just that one comma this entire time messing it up? I think it was. That's pretty funny. Okay, I think that fixes our parser. But we should probably test to see if everything builds. Yes, everything does build. That appears to be working correctly. I should be able to write in literals now, which is not actually something I was supporting for before, like the consts and whatnot. Let's try that out. And the unexpected value is intentional. Let's do times a 0.0. This is a... not a postfix, a suffix. Is a suffix. Yeah, it parsed it correctly. 0 type literal. Oh. Okay, it didn't parse the period. Is that the scripting language? Yes, this here is generally what the scripting language is going to look like. Very Rust-inspired syntax, though I do have anonymous structures, which kind of makes it lean a little bit towards, I guess, TypeScript too, but very much statically typed. We're not having any of, yeah, it's not going to be dynamically typed basically at all. I kind of want to go as crazy as being so statically typed that it doesn't let you pass a number that can be negative into like a division operation. That's the amount of like typed language I want to create, but it would take me way too long to actually get that working. And I'm already like several months longer into this than I like want to be. I love making the language, but I want to use it. So I'm gonna settle for just like, we're gonna get something working with like Rust style traits, and then somewhere in here we're gonna get a find types in, which will be like a simpler version of Rust lifetimes, but not exposed to the user. You'll never have to write a lifetime. It should be all automatic. I have a theory for that I want to, checking if it's negative would require runtime checks. No. Well, it would require runtime checks, but the way that the type system would work is if in your code somewhere there was like a if I is not equal, or if value is not equal to 0, or if value is greater than 0, or if value is less than 0, or if it's greater than or less than some constant, the type checker would be able to go, this code here checked if it was 0 or not, or this function signature defined that this type is non-zero. Then you could statically check for if the coder themselves already did a 0 check. So it's not that the type, like the it's not that you're doing a runtime check, it's that you're enforcing the coder themselves to do a runtime check at some point. It's like compile time checks if the syntax is being misused with negatives. You could do it with like negative values as well. Right now I'm thinking like non-zero for a division, but you could also do like enforce that this value is always positive. That is something that you could do. But the closest system that is more common that I could think of is, you know how some languages will enforce that a variable is initialized before you use it? Like you can define the variable, but not immediately initialize it. But you have to like set the value to something before using it. It would be like that, where it detects like, have you checked what the value of this is and compared against some constants? Okay, the compiler can now figure out like that if a like more metadata about the type, not just like if it's set or not, but also like make some guesses about what's actually contained in a variable. And that's something I'm really interested in looking into at some point. Oh, by the way, this error right here, that's a Brane script error. So this is good that we're seeing this. This is not good. I want to move on. I want to move on and get, like, start working on... I'm like 4 hours in, I should stop streaming altogether. But I wanted to get to HIR lowering. That's what I wanted to do. But the grammar... I got sidetracked on grammar and now I'm stuck here. Because this right here, this should be 1 token. So let's look at the Lexer and see if we can fix this real fast. So right here on float, a base 10 integer, then a period, and then another base 10 signature, or not, and then an ASCII identifier, or not. It should be a 2 slice. Where am I getting this secondary suffix from? Oh right, ident's already a string. So I guess I don't have to do the suffix. Oh wait, do I have int before float? Yes, I do. That means it will always parse an int before it parses a float. Just an order operations thing. So now if you look here, look at that. We have a float. But this one is also a float now, which is fine. That's fine for now. We'll figure it out later. How to actually properly handle this. What I probably need to do is... No, what I do need to do is figure out float versus integer in this parser instead of in the next one. Don't care about literals too much at this precise moment, because this is relatively easy to fix, just time consuming. I really should go to bed. I've been streaming for 4 hours. Thank you. Yeah, so this is the token tree itself, not the AST. The AST is a different tree. Actually, no, is this the AST? No, yeah, this is the tree, because we have, like, the groups in there. So this is Rust style. Token trees, not an AST. Because we failed to build the AST. Which, let's make it so we don't fail the AST real fast. Not yet implemented. Ah, right, because the suffixes. There's our AST. Much less clean, but hey, it works. Yep, there's our literal float. Yeah. Yeah, let's just handle this now. Here I'm just gonna do number Why is my editor crashing? Oh no, I didn't mean to close that window. Alright, thank you for sticking around while you could, though. So we're just gonna do a generic number. Just gonna be the start of float. It's actually going to be a choice between this, which it will try first, and then just the regular text, which it will try second. Then here, this is to slice. And this is also to slice. And then we're gonna have a float suffix, which is choice between so we have float suffix, and then we have int suffix, which is I32, F, or I64, U32, I30. U64. And then I guess U size is here too. And that's the majority of int suffixes, I believe. So now, if we do this one, you can say to slice. This one also to slice. Say then you can say float suffix. And on this one we can say or not int suffix or float suffix or not. And I believe these two have the same exact signature, so we can map it. Actually, no, we can't map it. So this is the symbol suffix. We can do symbol suffix and then lit kind. Need to do a match regardless on the actual int suffix. Which, like, this is where I'm like, you know, why don't we just store in the tokens what sort of suffix it is? No, I would need to do a map. Or a match. This, we're gonna say number suffix here. Now the problem is this number can be an integer. We're gonna to slice this and then map it as a literal kind integer. And then, whoa, my entire PC just lagged out there. And we have a float suffix. And that, with that, we can now do one singular mapping. Since we've actually put the, so we have the number there, and then we have the suffix and I'm gonna put the or not on the actual suffix itself. That way, I can just directly grab the kind out of there. Expected symbol found string. Oh, here's where expected symbol then found string. And now when we do this, we get number. And theoretically that fixes all of the problems with prefixes. So let's bring up our test script. And let's do... Well, it should have errored on this because that's not valid. I guess it just stored it as an identifier. Yeah, see, now I'm interested. Why did that work? Maybe I should have done a trimap. No, a trimap would have still had the same result. So it would just just fallen back. Okay, so we have 0, which is type float, 0.0, which is type float implicitly. We have 0, which is of kind int implicitly. Another 0, which is type int implicitly. 0.0 type float implicitly. Oh, I just realized all of these are suffix none. All of them are suffix none. Dang, I need to do keyword. Text ASCII. Let's see, this is going to be the same lifetime error as before. Likely. Yep, and then it has that. Keyword S is borrow. There has to be a way to get this to work, right? Oh wait, what if I do string new? Okay, so it needs to be a borrow. Well, since this is absolutely nuking my lifetimes, I am literally just gonna copy this. And throw it into another one of these macro rules. And that should work. So now, instead of text ASCII keyword, which doesn't work, we just use our own keyword macro, which is a literal copy paste of the code, and that will work. Type annotations needed. I need to work on this outside of a macro so I can actually get syntax highlighter. So it's not complaining about that, but it is complaining about this. Okay, no, it is complaining about this. Cannot satisfy input. Text, ASCII, keyword. Actually, I can just copy this. Which I didn't realize was still here. I thought I had deleted it. It'd be easier to put a found in there, but now let's comment out our keyword test and see if the other ones hold up. Oh, it wasn't working because of grammar error. Well, I hope it's working. Your stuff is working better than my stuff's working. Ah, so I need to manually do that too. See, I love traits until I don't love traits, because they're really deeply nested and stop working. And theoretically that works, now that I've copied the version of this that is working. So now to check. Does having a suffix work now? It does not. Having a suffix does not work. Even though I got keyword here to compile. Alright, I'm gonna put an intentional grammar error in, that way we don't get an AST. These just might have been working. I'm gonna put a print. Just in keyword against AST. And how long will it take to compile? Yeah, if you want to send me that video, that sounds interesting. Oh, I stopped it before it got to the AST phase. But I can already see that. Oh. It was maybe working this entire time, but I was dumb and said F instead of F32 or I64 or F64. Still saying suffix none. For F32 at least. I put the multi... Oh, come on, Vim. You're supposed to be the fast editor. Sounds cool. Alright, so I have this one as a float suffix, which is F32. Zero F32. So why is the suffix not working on that one? But it does work on the one right beneath it. The I32 in suffix is working. And the F64 suffix works on that one. Zero invalid, that's expected. Maybe it's because the or not. Then we do or not, and then we map this. So we do have to do mapping on these individual branches, which is something I wanted to avoid, but it looks like it's inevitable. Here we do suffix map. And then this is just going to be the string, and then we need the S. We need the secondary arg, which is the actual type, and then on this one, we do an unwrap. An unwrap or lit kind. Int Then we're gonna throw this in here as well. But we don't need to actually map it, because we know that this will always be float. Alright, I will look at that when I'm done with stream. Okay, I think it actually worked this time. You can see suffix none. Suffix none on the ones that is supposed to be none. This is correctly an int, this is correctly a float. And here we actually do get suffixes. In here, it splits this out into an individual identifier. But we don't actually get to the point where we handle these correctly. You know what, since this is what I'm doing for the rest of the stream already, let's just get this working. Even though it's objectively not what I want to be working on. Like, I don't want to be spending 4 hours on getting the suffixes to literals working. Heavy agree on the use of floor textures. Just like good textures in general. What was I doing? Right. The parser. So here, on the suffix, now we already know that this will actually be correct now. So we're just going to match on a suffix. I'm gonna throw an unreachable in here. And then, which one is this? Int. So we need to go to back to the lexer. There we go, I-64. But that's not the one I wanted. And now we do this for unsigned. No, not F. Unsigned. So funny how they're separate enums, but they still have the U prefix on all of them. Okay, and then... Oh, it's complaining about int type because of the name. And there we go. We should now correctly parse literals with prefixes. Alright, that completed successfully. Let's actually double check to see if the AST contains the stuff we want it to by removing the error, intentional error, and searching for literal. Kind. Yep, there we go. Float, symbol, suffixed. Those are in our AST. But I have a question. Why is this valid? I realized I never ended up using the this print statement up here to check if it was actually working. Oh, right. Invalid. Dang it. Invalid is going to be a symbol. So what we need to do is figure out what grammar is allowing this. Because we should be getting an error like unexpected identifier. That's what we should be getting. So we'll just search for lit in the grammar. We want one of the I know how to identify it. We'll actually make it be a number. And then we can search for that specific number, and it should default to an integer, which means it will show up in the AST. Yeah, there it is. There it is. Okay, which expression is this inside of? Inside of this expression, which, if I don't move the mouse, it thinks it's inside of a binary operator. Specifically, a binary add operator. Vim, are you dead? Oh, there we go. So if I also put A, B, and C in here, like more identifiers, does that cause an error? No, it doesn't. Why doesn't it? Dang, now I have to make pretty printing for HIR. Just so that I can read the debug info. Yep, that's a binary. Expression kind binary. This is inside of another binary operator, kind of multiple. The last multiplication is all the way back here. What's happening to ABC? Yeah, I'm not super confident that I implemented math correctly. What happens? If I copy this entire file, entire file copied. No! No, not my internet! Okay, good. Big tech company problems. Okay. We're gonna say write display or implement the display trait for every struct in this file. Give me the result as an uncommented block of code I can append to the end of my file. Assume all external types already implement the trait. All right. Let's see if it one-shots it. Vibe coding stream. You know, I have actually been looking into potentially hooking up a local LLM to my editor here. The editor that is currently completely crashed out, apparently. Did this one uncrash itself? No. Okay, let us see if... Oh man, it didn't even yap. It just gave me the code. Now, to see if there are any errors. Symbol doesn't implement format display. You know what? Let's implement format for symbol. I think it makes sense to actually have a display for it. Oh, come on, there's a code action available. Not a high chance it doesn't come out cursed. I'm expecting it to come out very cursed, and I'm kind of looking forward to it, to be honest. Path display? Why did you import path display? Brane seed tokens tree ident doesn't implement standard format display. I could have sworn it did. But maybe not. Ident symbol. Self-ident symbol global confirm. Yes. Yes. Ah, there's only 2 left. Yeah, it's just a ton of boilerplate that now I don't have to write. The pattern will always match, so the if let is useless. You're right. That is really funky, right? Hit it right it that way. Yes, we'll use if let to unwrap this variable. Actually, you could have just wrote self find expression. Or oh, there's only one. Okay, that's why you wrote it that way. I do want to replace this with a match statement. Well, that's several hundred lines of code I potentially just got out of writing. Potentially. The great thing about Rust is I know the code will at least run. Will it look nice? I don't know. But we're about to print it and find out. AST doesn't implement format display. I thought I told it to do it for every type in the file. There's struct AST. It didn't implement it for AST. It did for item, but not AST. That's pretty funny. And kind of cursed. So we have items. Item doesn't implement. Standard format, display. No variant or associated item named function for enum item in the current scope. Item. Pipeline. It's not reading my own code anymore. It's thinking it's the Rust compiler. Group doesn't implement format display. Pipeline doesn't implement format display. Screw you, ChatGPT. I should have had Claude do it. I'm just gonna paste it in because I'm sure I nuked whatever context window it has. Which is why I did not want to write this myself. Okay, let's see if I had any re-implementations. It's a good sign if I do. Wait, it says group already was displayed. going on here? This is like a half finished. Assign operation kind. Am I actually okay? This is the first one. This is the second one. Significantly less fancy, so I'll delete that one. Alright, on a whim, I'm gonna keep the second one. At least I did it for expression kind, because look at that huge chunk of code. Yeah, glad I didn't have to write that. And hopefully it looks good, so I don't have to write that. Okay. Hey, that's not terrible. It is kind of terrible, though. I'm not really able to tell what's grouped with what. So I'm going to look at the binary operators, the main thing I care about here. So oh, for expression kind. Binary. Left hand operator, right hand side. Hopefully that makes it slightly more readable. Invalid ABC is still just floating out in the ether. What's printing them, though? Because, like, these should not be printing. Unless. Where is block? There is block. This is extremely cursed. Yeah. See, it's picking this up as an expression within the block, because Rust has this thing where the last expression in a block, if you don't put a semicolon over it, it returns that value. So, what's going on is it's treating these as expressions without a semicolon, like return values. Because technically, the way the grammar is laid out, you can do that. Like, the data structure supports them being interchangeable in order, the AST in particular. So, what I'm going to do is... There it is. Statement repeated. Choice between a local Dang, they just... I don't like it getting that far down into the tree before it becomes valid. I guess we'll just account for that when we lower to HIR. But it does look like everything's there, so that's good. So I'm gonna say... Alright. So that is now pushed up. And we have now fully implemented, potentially, fully implemented the data structure for HIR. And we have now confirmed that most of the data we want is actually making it through. Though there's definitely a ton of bugs that I haven't fully accounted for yet. That I will figure out as soon as I start actually using the language, which is why I want to start using the language before it's even done. Next up is doing this lowering phase, which we get to do next stream. Or me when I'm like working on this, not on stream. We'll see. Hopefully that's an on-stream thing, because I think that's like a really cool thing to build on stream, is the actual like, then we're actually doing work. We're not making data structures. We're actually solving problems, instead of going, why does the bar checker hate me? Alright. Yeah. That is the end of the stream for today. We will see how much time I have to stream other days. Yeah, I would be down for that too. But yeah.